Hello everyone, welcome to another video of Calculus 1. In this video, I'm going to talk about how the mean value theorem of calculus is used to find increasing functions, decreasing functions, and also test the critical points of a function. So we know that if function is increasing, if a function is increasing, its derivative f prime of x is greater than 0 for a given interval a b. If function is decreasing, its derivative is less than 0 for the given interval a and b. Let's take an example. This example is very simple example. Let's take f of x equals natural log of x. In that case, we can find d over dx f of x, which is f prime of x, which is equal to d over dx natural log of x, which is equal to 1 over x. So for the domain, which is x greater than 0 domain, all the positive values, f prime of x is positive. That means it's an increasing function. The second example, find the intervals on which f of x equals x squared minus 2x minus 3 is monotonic. Monotonic means whether it is increasing or decreasing, right? So now first we want to find the derivative. We want to find the derivative d over dx f of x, which is f prime of x. You have 2x minus 2. So then uh, we can see that f prime of x is 2 times x minus 1. So if I draw in the number line, the critical point would be x equal 1. So any value less than 1, for any value less than 1, this is negative. For x less than 1, f prime of x is less than 0. That is, it is decreasing. So values, this side is decreasing. And then for values x greater than 1, f prime of x is greater than 0. So this side it is increasing. So I can say that from negative infinity to 1, f of x monotonically decreasing. For values from 1 to positive infinity, f of x monotonically increasing. And then we learned that we can test the critical points by looking at the sign change of f prime of x. If the sign of f prime of x goes from positive to negative at point C, then FC is a maximum. If the sign of f prime of C goes from negative to positive at point C, FC is minimum. So we're going to use that uh, consequence of mean value theorem to solve the next few problems. So we are given a problem example. Analyze the critical points of f of x equals x cubed minus 27x minus 20. First, step 1. Find critical points. How to find critical points? You have to find f prime of x, which is 3x squared minus 27 minus 0, right? So when we set f prime of x to 0, we get critical points. So I have 3 times x squared minus 9 equals 0. That means x minus 9 times x minus 3, x plus 3 equals 0. X equal 3 or x equal negative 3 are critical points. Now we are trying to put these numbers on a number line. You have negative 3 and positive 3. This is negative infinity and this is positive infinity. And then we're going to look at the behavior of f prime of x. Now f prime of x is equal to 3 times x minus 3 times x plus 3. Now if you put any value less than negative 3 in this region, I'm going to analyze this region first, right? Any value negative less than 3, this is negative and this value is negative, right? Sorry, this value is negative, this value is also negative, then negative times negative is positive. So you can write this is negative times negative and becomes positive, right? So if you put any value in between uh, negative 3 and positive, let's put 0. 0 is in between this, right? 0 is right here. 0 is right here, right? So I put 0 because that's the easiest value to substitute. Put 0. When you put 0, this is negative, this is positive, and then it's negative, right? Because you have a negative value times positive value, which is negative, right? Or negative. Now, at the critical point negative 3, the function value change, f prime of x value changes from positive to negative. when it changes from positive to negative, it's a maximum. So x equal -3 is a local maximum. Now let's look at the last region. The last region is beyond 3. Let's put 4. When you put 4, this is positive, that is positive. So positive times positive is positive. So you have positive value times a positive value that results in a positive value. So now from here to here, from in the in close to +3, the value of f prime of x changes from the sign of f prime of x changes from negative to positive. So when the value changes from negative to positive, it's a local minimum. So this value is x equal 3 is a local minimum. So here the function is increasing, and f of x, so f of x is increasing, and in between that f of x is decreasing, and again f of x increasing. Let's take another function. Let's take another example. F of x equal cosine squared x plus sine x in 0 pi. First find critical points. Step 1, always find critical points. So you find f prime of x. F prime of x is equal to d over dx cosine squared x plus d over dx sine x. So this is 2 times cosine x times d over dx cosine x plus d over dx sine x. This is 2 times cosine x negative sine x plus cosine x. So if I take out cosine x, this would become 1 minus 2 sine x. That's f prime of x. So when f prime x is 0, then you get cosine x times 1 minus 2 times sine x equals 0. That will give us cosine x equals 0, or sine x equal half, right? So when cosine x equal to 0 in the range in the interval of 0 to pi, cosine x could become 0 at uh, cosine x could be 0 at pi over 2. Cosine x could become 0 at pi over 2, and sine x could become half at pi over 6 and 5 pi over 6, right? So answers for this equation, right, in between x equal pi over 2 or x equal pi over 6 or x equal 5 pi over 6. So in between that number line, we can go from 0 to pi. So you have pi over 2 here, and then pi over 6 here, and then here somewhere here pi over 6. So these are the it divides into uh, 1, 2. So from here, right, it starts from here to here. 1, 2, 3, 4 regions. Uh, 4 regions. So we have to analyze what happened to f prime of x in these regions. So let's remind ourselves what is f prime of x is. This cosine x times 1 minus 2 times sine x. So we can put any value in between those values and identify what's going on to the function value. So I would try uh, if I try some value like point pi over 6 is the uh, pi over 12 or something like that. So then you have the cosine value is equal to positive, and then the sine value is equal to it's always less than 1. This is positive, right? Because that's whatever the value you put with sine uh, is positive in that region. So you put this is a positive region. And then if you consider uh, pi over 4, in between that you can get uh, square root of 2. This is negative and this is positive and a negative value. And then you can put maybe a 2 that's equal to positive value, and then you put equal 3 or something like that, and you find that is negative. So this is in this region function is increasing, and this is decreasing, increasing, decreasing, right? So increasing and decreasing, this is a maximum, and decreasing and increasing, so this is a minimum, and increasing and decreasing, this is a maximum. So you have two maximum values and one local minimum value. Uh, yep, because of the sign changes of f prime x6. So when let's get another special case where critical point when f prime of x undefined. So we talked about this problem previously as well. Let's take f of x equal 1 minus x to the power 2/3. So you need to find critical points. Then that means you need to find f prime of x, which is uh, negative 2/3 uh, 1 minus x to the power negative 1/3. Uh, so at uh, x equal 1, f prime of x does not exist. So that means it's a critical point. Now we're going to look at 1, and then this is positive infinity, negative infinity. Sorry, this is negative infinity. This is positive infinity. So when you look at any value less than 1, let's put 0 here, and it becomes negative. So this is negative f prime of x negative. And if you put any value uh, greater than uh, uh, that, f prime x is greater than to 1. So if you put 2 in here, you get a negative value. We have a negative cubic root of negative value is defined. So you have negative value for this. We put 2, and it's going to be negative 1. So this is positive value. Everything is positive. So we have positive value. So the function is decreasing here and increasing here. That means at 1 it is a minimum. It is a point where actually f prime of x does not exist, but you can find whether that critical point is a minimum or maximum. So with that, I will conclude this video. And if you have any questions, please post.